Okay. Thank you for showing up for my presentation. This morning when I got up, I was nervous for not having anybody show up for mine, but now I'm really nervous. Before I begin, I'm just going to say a few words in French, and I'll come back to English. Bonjour, je me présente, je suis Alain Casault, et la présentation s'intitule « La haute disponibilité pour les PME ». Compte tenu que les Québécois qui travaillent en technologie sont pas mal de facto bilingues, compte tenu qu'on a l'autre 9/10 du Canada, des Américains, des Européens, puis là, je viens d'apprendre qu'on est sur YouTube Live, aux joies, au bonheur. Je fais ma présentation en anglais. Cependant, si vous avez des questions, j'ai une période de questions à la fin de la présentation, donc gênez-vous pas, posez-les dans la langue de votre choix, puis je vous répondrai dans la même langue. Okay, so back to our regularly scheduled show. My name is Alain Casault, and I'll be presenting high availability infrastructures, or say that real fast 3 times when you're a Frenchman, for SMBs. First of all, about me, I'm an electrical engineer, and I've been working over 20 years with in telecommunications, various OSs like Windows, Unix, I'm old enough to remember Unix, Linux. I've dealt with many different types of companies like privately owned government entities, state-owned entities, and I also authored the latest version of NTCNA course material, which new users and new trainers can use if they wish to. And my wife and I, which is sitting right there, allô chérie? Oh, am I going to sleep on the couch tonight? We founded the company called Centre de Services Professionnels en Éducation. We specialize in educational services. She deals with the younger crowd. She's a special ed teacher, and I deal with the older crowd, the adults. So I give MikroTik courses. I'm certified CNA, CRE, and I've just been certified wireless engineer. I do French English. And I've also introduced 2 courses, Introduction to TCP/IP and Introduction to MikroTik routers. I've done this because I've had students with little or no experience show up in my classroom. And I mean, if you've ever seen a deer looking at the headlights of an SUV running towards it, that's what I was seeing. So I'm hoping that these 2 extra courses will help the guys get a better grade when they do the certification exams. Okay, today we will see what high availability means and how to use MikroTik equipment to build a robust and flexible network. We'll begin with some theoretical aspect. We'll touch about the concepts of HA. And by the way, I will say HA as a Frenchman, it will be much simpler for me in my tongue. We'll see also what the major causes of downtime are. And we'll also see a general example of what redundancies should look like for us in our IT rooms. Then we'll delve deeper in the technologies that I'll be talking about, and we'll have a pre-recorded demo. I am not so masochistic that I will do a live demo today. Those never work. I've classified my presentation as intermediate. To get the full of today's presentation, it would be good that you have a good understanding of router OS and the general concepts of networking. Okay, to the meat and potatoes now. Wikipedia defines high availability as a characteristic of a system which describes the duration, length of time for which a system is operational. I define HA as uptime, I keep my job time, and happy boss time. And isn't that right? When people talk about HA, it's always attached to a percentage score, and we always also hear about the dreaded 9s that follow that score. So basically, we all know, for those who've had the problems of dealing with HA, those 9s mean big bucks. So what do they mean, these 9s, at any rate? So I've just grabbed this from the internet, and as you can see, the first row is 1 9, and the last row is 9 9s. Now, I don't know about you guys, but I'm not so fast that I can fix a bug in 32 milliseconds, even if it's once a year. Now, obviously, these scores are totally biased and unrealistic because we haven't factored in scheduled downtime. So when we create an infrastructure, we go to our client, either it be our boss or the client of our company, and we will have to negotiate downtime, which in turn means that we'll have a realistic uptime score. What are some of the downtimes? What causes some of the downtimes? First of all, we have hardware failure. Who has never had a router go poof, even if it is MikroTik router, right? Network failure. I mean, you've probably put in 1 instead of 0, the comma instead of the colon. We've all done that. Human error, system overload, electrical supply. Just show of hands here. Who has ever caused an outage, by mistake, of course, in their networks? Oh, yeah, I'm not alone. Cool. Okay. SAQ, Thursday afternoon, 5 o'clock. I brought it down to its knees. I mean, for those who are not from Quebec, that's the Quebec Liquor Board, like LCBO and so on. My boss was good to me because I came up and I told him, and he told me, you had the right for 1 mistake a year, and you just did it. And for sure, I thought my buddies and from the DBAs would kill me, but they got so much paid overtime, they actually liked me. Okay, so now, HA, what would it look like in a dream scenario where money was no object? We have double core routers. We have double links going to switches. Ideally, and my server buddies would probably agree for dual NIC servers. We have 2 ISPs, WISPs. Of course, obviously different ISPs. You don't want to go to Videtron or Rogers, and if they go down, both your links go down, right? You'll have dual electrical supplies and everything. You have trunks, you have VLANs running all over the place. About the only place that you won't double over are the NICs in your PCs and printers and phone. I mean, there are limits to how paranoid you want to be in life. Okay, topology. So how do we get there? As we've seen in the previous slide, we have duplicate hardware, duplicate links, duplicate electrical supplies. Electrical circuits, 120 or 240, power supplies inside the routers. Now, is Mr. Strika here? I know the gentleman from MikroTik, I believe, will have a word on that on his routers this afternoon about dual power supplies within your routers. But doubling everything over is not the end of it per se. You will have to have proper configurations like VLANs, VRRP, and other various optimization, which I'll touch upon in the coming slides. Having fun now. Technologies. Legal disclaimer. What I'm going to show you, I made for the purposes of this demonstration. It's small, it's fast, and it worked. That was my main goal. And we're a big group here. We could probably have our own ideas and suggestions on how to make what I'm going to present. Like I said, this is just for demonstration purposes. First of all, I'm going to talk about flexibility. Merriam-Webster defines flexibility as characterized by ready capability to adapt to new, different, or changing requirements. So what does that mean? You want your network to adapt quickly to organizational growth, demands, and changes, while at the same time minimizing those costs. So what do I mean by that? We all started one day creating our network, and we were pretty much wet behind the ears. We had one subnet, be it switch or most likely hub in my days, one router, internet access, and woohoo, we were king of the mountain. People, oh, by the way, all the colors are different departments, and I mean, we could go on the internet, surf whatever we weren't supposed to surf, and it worked, right? Until one day, design confronts reality. Your boss comes over, he says, we're expanding. I want the yellow group to go on the 2nd floor, but one guy from the yellow group has to stay on the 1st floor, but he still has to be plugged on his network. Oh, great, another cable to pull. And the one guy from green and red are going upstairs, but they still need to be plugged downstairs. Oh, great, 2 more cables. Oh, and by the way, the red guys are playing so much Halo that they're really slowing down the network, so I want to isolate these guys. I don't know why you just fired them right off the bat, but hey. So what do? We implement VLANs. So VLANs are a layer 2 technology that we use to partition networks into virtual broadcast domains. No, layer 2, well, it's like putting two hubs or two switch side by side. Layer 3, yeah, I was expecting that question. Isn't like layer 3 supposed to cut broadcast domains? Yes, it is, but even if you have a managed switch and you do two VLANs, you won't hear the VLAN 1's broadcast over VLAN 2, right? It'll just cut right there. Okay, so my second design, having been burnt by reality after meeting the design, would look like this. You have one switch on both floors. You have just one cable being pulled to each floor, simple. And then you have your VLANs being propagated all over the place. So no matter where your boss decides to sit your employees, it's only a matter of going back to your router or switch, a little commands, a little apply, okay, and you're done. Now, when you want to configure VLANs, how would you go about doing that? First step, and again, this is my suggestion because I know you can do with switch chips, but I'm a lazy bastard and I like bridge interfaces. So the first step that I like to do, I create a bridge interface, which I call BR trunk. Well, you may have guessed bridge trunk. Oh, by the way, when I give the courses and when I program my routers, I emphasize one thing amongst others: make meaningful names. Because if you put trunk or bridge, blah, 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 it won't speak to you. So to me, for me, this means it's a bridge for trunks. Second step, you create all your VLAN interfaces one by one, and you've noticed I've created two, X, Y, Z. Under this bridge interface, third step, I mean, if you want trunking, obviously you need at least minimally one physical interface. So I've programmed one interface under the bridge, which will be the trunk. So that's the trunk recipe. Second step, I want to create regular VLANs. Now, before going, I have one more slide to show you afterwards, so just wait. First step to make a VLAN work, in my recipe again, you create another bridge interface, which I called, in this example, BR-VLAN X, the X meaning 1, 2, 3, whatever you want. Second step, I take this VLAN interface, which was already configured from the previous step, and I assign it here, and also you've noticed I've given it an IP address. Now you're going to say, well, this is where people would go, well, where do I put my PC? Well, this is just the two steps you need to do to make your VLANs work. Now, if you want to plug a PC, this is the third slide. Now you will create an access port. This is already there, we saw. Just grab a port, assign it into that bridge, and now you have created your first access point. So previous slides, we saw we had one trunk port. Now we have one access port. So how do we do it? I like CLIs. Probably a lot of you do also. I mean, this will speak volume. Again, as a resume, one bridge interface to host them all, and one bridge interface per VLAN. So in the end, it will look like this. The bridge, we have three bridges, one for the trunks and one per VLAN. Now, when you create your VLAN interfaces, what you'll need to do is, these are the CLI commands. Now, I want to bring your attention to the blue circle right here. When you look at the MikroTik web pages and the forums and the wikis, they always use, it's not MikroTik, it's like the people who feed the page, they always use Ether5 as an example to just demonstrate how the concept is done. Well, that's okay and it works, but the recipe I proposed right this morning is you don't want to create an infrastructure where your Ether5 is hard-coded as a trunk, and if you want to change something around, you have to go through your entire configuration and start wondering, am I missing something? If you use bridge interfaces, if you want to just take 5 and put 3 in its place, it's just a matter of reassigning, and that's it. 3 becomes trunk, and 5 becomes whatever else you want it to be. That's a little heads up I just wanted to bring to your attention. Next step, where am I? Okay, the trunk port. Yeah, now we've done the bridges, we've done the VLANs. Now we're going to start binding stuff together because we have the ingredients, but we still need to make the cake. Now, to make your trunk ports, you're going to take one or more physical interfaces and bind it to your bridge interface. The VLANs in the access port. Again, I must emphasize the first step is a must. Without this, no VLANs. So you bind your VLAN interface to that bridge interface. And lastly, you will take one or more physical interfaces and bridge it to that one bridge VLAN interface. And now you have just created one or many access ports. So what does it look when you look at the CLI? Well, basically it. So this example, what it demonstrates is you have a trunk, and you have one access port, and whatever traffic comes here will propagate through that bridge interface, and if it's meant for some other router across a trunk, well, it'll just flow over to this VLAN interface. And finishing touches, well, yes, you'll need to do some IP addressing for your bridge VLANs. Now, I emphasize here, trunks being layer 2 don't need, obviously, an IP address. You'll create your DHCP servers, again, on your VLAN bridges. Again, trunks being the layer 2 don't need servers there. And you'll finish off with little inky-dinky parameters that you really need to make the whole pudding stand together. You'll configure DNS, NTP, identity, etc., and so forth. Okay, yes. So now we've seen, and maybe this, for a lot of you, this was, yeah, I'm doing that, and I get what I see where you're going. This step is interesting. Now, you have to optimize STP priority. So how this is done, you will open your, for example, in my example here, your BR VLAN bridge interface, and you'll notice it has a priority setting here. By default, it's 8,000 hex. So what I've done in my, if you remember the diagram in the beginning, we had two routers, master, backup. The master, you'll give it a 1,000 value in hex, and the backup 1,001. Yes, this is maybe like going against our grain because we're used to bigger number, bigger priority, but that's not the case for STP and RSTP. So again, if I repeat, master 1,000, backup 1,001, and you keep the STP priority for the other devices at 8,000, their default. So why would we want to do that? Well, let me tell you about the forgotten bridge. Okay, so much for my Vincent Price imitation. Okay, this, I kid you not, it happened to a friend of mine, and it was a very big mystery for him, thus the Scooby-Doo mystery machine. He had finished upgrading his entire network. I mean, well, it was modern back then, but the thing is, he had forgotten one little inky-dinky two-port bridge, and it was left behind in a photocopying machine. So whenever somebody would come around and wait for his 100-page job to finish printing, what does the usual ADD guy do? Click. Okay, light turns on. Cute. Waits around. The light's boring. Click it off again. He would turn the bridge on and off again. So what do you think happens? It forced the entire network to reconverge every time at a layer 2 level. And then the boss would storm into his office and your network sucks and it's not stable, it's not sturdy. And worst of it is that particular bridge had a higher priority than all the other switches' default priority. So of course, whenever the state of that bridge would change, the entire network would converge. Luckily, he found the culprit, and he smashed it with a 20-pound sledgehammer. I remember that day perfectly. It was beautiful. And he kept his job. Okay, next optimization, which you would want to look into. Again, when you open one of these, the physical ports, two parameters that you'll see are edge and point-to-point. So when you know that this particular port, Ether 4, for example, plugs a PC, a printer, whatnot, and it's not going to be a switch or a hub, I suggest put it to yes. So you tell the router that that port is an access port. And if it's a trunk towards another switch, leave it to no. So what that does, it's going to shave off a few seconds from the RSTP negotiation. And now because of the nerves, I'm losing it. Yeah. Well, remember discarding, learning, and forwarding states. So when you put edge to yes, it goes right away to forwarding, and you shave off about maybe like 10 seconds of waiting time before your traffic can start flowing again. In Cisco, yeah. And then point-to-point, if it's a full duplex link, put it at yes, and half duplex link, leave it at no, and again, you'll shave a few seconds from the convergence states. Okay, so obviously, why do we do this? We want to speed up convergence, and also, and this also I emphasize a lot when students come to my classes, you want to be able, as sysadmins, as designers, to be able to predict and say exactly how your network's going to react. I mean, what's the use of creating master backup core routers when it's your third floor switch that's RSTP master? I mean, it's kind of useless. You don't want like a network, don't want to create a network that's a total surprise for you. Water, best invention in the world. After beer. Redundancy. Merriam-Webster defines redundancy as a part in a machine, system, etc. that has the same function as another part and that exists so that the entire machine, system, etc. will not fail if the main part does. So, well, I guess the answers are pretty obvious here. I mean, you don't want downtime because you don't want the loss of productivity that comes with it. You don't want the loss of revenue. And if you're a service provider, a consultant, an ISP, whatnot, usually those dreaded SLAs probably carry a lot of cash penalties for you guys. And we're all working very hard to make our money. We don't want to give our money to customers because our infrastructure wasn't as sturdy as it should have been. So if we remember, our second, when we left off with VLANs, this is what our second design looked like. Until, once more, design meets reality. We lose the router, so we're begging and groveling and bootlicking, to not use an A word, so we get to keep our job, provided that this incident does not reoccur ever again. So now we've learned. We started from doing flat network, we've learned about VLANs, and now we've learned about redundancy. So what are we going to do about it? We're going to use hardware redundancy, link redundancy, and we're going to touch on VRRP. So now that we're bigger and better and stronger, this is what our third design would look like. So now what happens is, should our network experience up to 2 outages, which is the case here, our traffic would still flow. So traffic outbounds like this, inbound, well, I've simplified the green line, but you kind of guess it would go through here and back here. So we could lose 2 links, 2 outages, and you still get to keep your job. We could lose an entire router, and you still get to keep your job because what you did actually works. So is hardware redundancy enough? No. We're going to look at VRRP now. So this protocol the acronym stands for Virtual Router Redundancy Protocol, and it's a protocol that assigns the responsibility of a virtual router to one physical router inside of a group of 2 or more. Obviously, you can have a group of 1. And it shares also the control of a virtual IP to that active router inside that group. So why should we use VRRP? Well, as we all know in telecommunications, our PCs, printers, need a default gateway to just get outside to another subnet. So VRRP ensures the availability of our default gateway. So this is how I visualize VRRP. So the yellow box is the VR1, virtual router. So this is what virtually exists now that we've used 2 physical routers, the green and the orange ones. in the VRRP mode. So if you look, and if you look back at a few slides, we've seen these three guys here. So we have VLAN alpha. Yeah, this example shows that I'll be making sure that VLAN alpha is redundant using VRRP. So we have our VLAN interface, which is bound to the bridge of bridge VLAN alpha. And we have a physical interface here that is bound here. Same thing across on the other router. The only new thing that we added on this cake were the candles, okay? VRRP interface we have. And please notice also, when I talk about meaningful names, VRRP, BR, VLAN alpha. So I know that it's a VRRP interface for the bridge that controls VLAN alpha. Same thing across here. And I've also said that you have a virtual IP that's going to be shared amongst the 2 or 3 or X, and it happens to be here. Now you'll notice IP address alpha and alpha, actually it's A. Yeah. It's A, then you have IP B and C. So do take notice, 3 different IP addresses. So how do we do this? Well, very simply, it's just basically another interface that we'll add. First of all, ask yourself the question, my first router, is it going to be the master router or the backup router? And do you want the routers to preempt? Now, what is preemption? If my left-hand router is main and goes down, well, my right-hand router goes, okay, I'm going to take over because you're obviously on sick leave. Now, when my left-hand router comes back up, if he's not preempting, he's going to say, well, stay there, you're doing a good job, guy. But if I am preempting here, he's going to say, give me back my toys, I want to play with them now. It's over. So this guy's going to go back into a waiting mode for my buddy to be sick again. So on my green router, what I've done is I've created 2 VRRP interfaces because I have 2 VLANs that need to be protected. Default priority being 100. I've increased the priority here, so now just because of this, I can see that this is going to be my master router for both VLANs. And VRID, well, by default, VRID is always 1, so don't forget to change your VRID. Otherwise, you're going to wonder why nothing's being nothing works for you. And on the second router, by default, preemption is always on, so you want to take it off. This guy is the backup router. It doesn't need to preempt because when you turn away, it's going to have a lower priority anyway, so it's kind of useless. So, pardon me? There's no delay. We mean like delay after a certain amount of time? No, it's either. You can't. There's no parameter like wait for a certain amount of milliseconds or seconds. I mean, it's either on or off. But the question is, can I delay the preempt? And the answer is no, because there's no value for that. But comes to mind a little thing I want to bring out. You've already experienced one outage because your main router went down, right? So sometimes on some sensitive networks, some people won't like to do is disable preempt totally, because when the other one comes back up, you don't want a second outage to hit you in the face. So some will decide, well, I'm going to wait until 5 o'clock when all my users are gone and the office is closed to just switch the priority over back to the main router. Okay, so next, so we've done, basically now right here we've done the interfaces, but there's no IP attached to it. This is where we are. So we're going to make an IP address using, well, first of all, obviously a free address. We don't want duplicate IP address. And the particularity of this beast is it's a /32 mask. So yes, I mean, if you don't believe me, go on MikroTik's webpage, grab the RFC, sorry. And it's a /32. And you will assign it, if I go back a few slides, right here. So let's say your IP address is 1111. Well, both of these routers will have 1111/32. The only difference now is if this is a progression of your design, as we've seen from the beginning, you're going from 1 to 2 routers, your original routers probably were 1 and 2. Well, now obviously this guy's going to become 0.2, and he's going to become 0.3. Wait, is that clear for everybody about the little Roomba with the IP addresses? And little piece of also this little note here: never have identical real and shared IP addresses. This is what we call owner mode, and not all routers support owner mode. MikroTik does not. So again, your VRRP interfaces will have, for example, .1, both of them, and the physical interfaces will have .2 and .3. Now, optimization, well, it's not really optimization. I should have maybe rewrote the terminology here. But when you design your VRRP, one will be master for all your VLANs, one will be backup for all your VLANs, and if the master fails, the backup just grabs the default gateways within a matter of 1 second, and that's over. And if your backup fails, well, who knows? It wasn't doing anything anyways. Now, I know some of you will probably be going, but what about load sharing? Keep that question in mind. I'll get back to it by the end of the presentation, because there would be a better way of doing this, and I'll explain why we won't be doing this right away. Okay, okay, now we have a layer 2 and layer 3 router network, and works fine. You'll obviously want to be doing some dynamic routing. Nobody in his right mind likes to do static routing, especially if you're beyond 3 routers. What I suggest in this case, you open your OSPF interfaces and you assign them, you change their priorities. Now, if we all remember, the default priority for interfaces is 1. What I'm suggesting today is your designated router, your DR, put it at 100. So whenever your routers come up, he's going to be the DR. Your BDR, give it 50. And your members, give them 0. They're only members. I don't think they need to participate in the OSPF election. As long as they get the routes, you're going to be okay. Now, again, you're going to do this to make everything predictable. You know who your DR is, who your BDR is, and who your members are. But OSPF, being the non-egotistical child that it is, I mean, if the DR goes down, BDR says, okay, I'm your new DR now, and when the old DR comes back up, well, the backup router will stay DR. So that's something that's OSPF, you can't change it. But again, if you might not want to cause a second outage, so you might want to leave that for the end of the day when all your users are gone, and especially the boss is not looking at you. One thing that's useful here, though, OSPF, lower your hello intervals and your dead intervals to make convergence faster. But of course, the hit on that is a wee bit more OSPF traffic. So it's up to you individually to evaluate what's good and what's not for your particular case. Pitfalls, oh yeah, maybe. Sharing personal experience. When you start doing high availability, I started off with fresh routers, no default config, nothing. So what did I do? Plug everything, start configuration. Bad idea, Joe, because spanning tree loops, traffic goes through the ceiling, CPU chokes down, and I'm not a happy camper. So when you start playing with setups like that, or any setups where you have possible loops, just configure your routers and plug afterwards. Okay, MikroTik guys here? Nobody from MikroTik? I had a wish for them. Jeez. No red shirts? Well, I'm going to say it anyways. Maybe somebody's going to squeal on me. I would like for MSTP support. Carlos, MSTP support. Why? Okay, because remember last time earlier I told you the way I'm doing HA right now, it's not as optimal as it could be. Let me go back to my... let's see. The joke is lost on them now. They're not even present. This is the demo that I used in my lab. Now, without MSTP support, or for those guys who know Cisco per VLAN spanning tree protocol, what's happening here is I'm naming this guy master layer 2 and master for VRRP. and this guy is backup. So what's happening? This port here is blocking, so all traffic on this switch is going through here to this router, to the internet, or what, server farm, whatever, and it's coming back. Now, if we had MSTP support, let's say we have 4 LANs, the odd-numbered LANs and the even-numbered LANs. Well, you could say this guy is master for the even-numbered LANs, and VRRP, obviously, and this guy is master for the odd-numbered LANs. So whatever traffic that goes on 2 and 4 would go here, 1 and 3 would go here and back, and at least now both routers would get half the load and half the work and all the pay, and all the links would not be topped at a gig or 100 or whatever configuration you have. And and if you have an outage, now that's a cool thing. Instead of, let's say you lose your main router, because that's the problem here. Instead of all your 4 VLANs being hit at once, you will only get half the VLANs being hit. Unfortunately, without MSTP support, we're not going to be able to get that. So again, and yeah, that was maybe my middle marketing speech for MikroTik, but again, they're not here. For those who want to migrate from Cisco, it would be so much easier for us to do, right? So I'm at the part of the unlive demo. So I've recorded, and let's see, because I have some sound, and I hope you like asterisk music. That's all there is. Okay, this is my setup. 2 demos. The first demo, I'm going to simulate this guy going offline. Second video, this guy is going offline. Okay. J'adore Windows. Hold on. Bon. Demo 1 core. Okay. Just for information, before I proceed, I had right here, I used another router with NetWatch just to be able to ping all the addresses that I had to ping. So, I feel like a preacher. Okay, so you have all the addresses I finished at by .1 are my VRRP interfaces. The .2 are the backup, the main core router, and the .3s are the backup routers. Okay, and here is the IP address for MikroTik, and this, I can't remember what it was. So it's pretty cool. The VoIP call, which was on hold, only lost maybe like 5 seconds total. And as we saw, the ping towards MikroTik's website suffered the same ill effects. And now, the second router. I guess you can pretty much guess what's going to happen being the core router, the backup. go back. No. Okay, so final words. What we've seen in this presentation was the flexibility of using VLANs, the redundancy of doubling links and hardware, and by using VRRP. And all of this put together, I demonstrated how you can achieve higher availability of your infrastructure, and also made you aware of certain things like optimization and steps to follow not to crash your hardware. I have some time left for questions if you have any. Okay, well. Sure, the first one or the second one? The first one or the last one? Actually, let's see one. Okay, hold on. Is it this one here? Mm-hmm. I missed a few of your. Mm-hmm. Okay, so if I'm understanding correctly, I'll repeat your question. You would suggest using scripting to just switch priorities from one router to the other. Am I correct? Mm-hmm. Like going like this? So, okay, because you're still having problem understanding all your question, but you're saying like disabling this link here? Well, again, because what you're suggesting is you're using automation to disengage or like remove that link. What I'm suggesting is I'm from an era is I don't want to create all of my tools, and by using MSTP or Cisco's PVSTP as it was, you still had to have that link in the middle, because if you do lose here and here without that cross link, well, your traffic's not going to go out to the internet. Yeah. Yeah, because, I mean, MikroTik is extremely flexible in what you can do, so stuff that's not included in our router OS, yes, you can work around it or band-aid it, but I don't know, maybe I'm too lazy, and I still yet have to learn scripting, so I think I'd rather have the full protocol support than having to patch my way through it. Well, thank you. Good comment. En avant ici?
My question is quite simple, actually. In the example that you've given, how do you set up your port master-slave relationship? Do you leave it all with a master port and they're all connected?
In this setup here?
Yeah.
Okay. The master slave for layer 2 or layer 3? Okay, well, what I've done, let's see. Like I said, if I go back to the layer 2, je vais rester ici. The layer 2 bridges, if we're talking about, well, the question first of all is how do I set up my interfaces? C'est ça? Okay, so the trunks, if we remember, we had 2 parameters that we had to play. The edge trunk here would be no because it's a trunk port towards another switch. So it has to go through the RSTP steps of listening. There were 3 steps. My memory's shot this morning, but there were 3 steps that you had to go through before the port would start forwarding. So these are, these would mark as edge equal no. You could put auto and it would start like doing a little extra mumbo jumbo, but in the effort of speeding up your infrastructure, I always like to hard code my configurations and answers. So edge and point-to-point, well, edge no, point-to-point yes, because it's full duplex. And the bridges here would have a priority of 1,000 hexadecimal, and here we would have 1,001 hex. Does that answer your question? No?
You know how when you have a router with multiple ports, by default it's going to be set up, the first port is going to be your gateway, and then the other ports, the first one will be the master, and all the other ports will be slave.
Oh, okay, that. Okay, well, okay, so the question here is, how do we set up all the Ethernet ports more at a hardware level? Okay, well, if all the ports were always on the same VLAN, you could have slave-master relationship. I personally don't like it because, well, for my environment, I don't need the performance boost as much as I need the flexibility. So in that setup, I would just leave all ports to no master, no slaves, and just bind them into a bridge.
Then you're offloading the work of routing, switching
To the CPU.
software.
Yeah, switching will be done through CPU. I know it's not optimal. And again, like I said, this is my recipe for this demo, but it's always good to look at what you need. And if your environment is very, very stable and static, you could go about going with the slave master setup. Yes? Attends, le but de la question, c'est si c'est un quoi, je mets? C'est ça, sont bridgés. Non, mais c'est ça, tu n'auras pas les mêmes steps. Il faudrait voir. Oui, tu pourrais passer par le switch chip. Puis, regarde, on va te faire une plug, là, vraiment une plug. Là. Va suivre le MTCRE. Puis, dans le code, il est monté, tu peux faire du VLAN bridgé software ou switché hardware. Puis, quand même que c'est tout, je reviens à ta question, quand même que c'est tout master port, oui, ça va marcher. Mais les étapes sont un petit peu plus... Ben, elles ne sont pas plus ardues. Un coup que tu l'as fait, tu l'as fait. Là. C'est juste une recette. Oui, tout à fait, effectivement. Puis quand tu vas avec le switch chip, tu n'as pas le choix de faire un setup master-slave. Tu es obligé dans la façon que... Ben, ouais, c'est ça que tu l'offloads. Là. Que j'avais, je pense, I had une autre question. Okay, just to make sure I want to understand your question, you're asking if there's something in the logs when a VRRP event happens?
Yeah.
Is that it?
We lose the other core and we lose the main core, we switch to the other core, and we would like to know we switch to the other core.
Yeah, obviously. Well, I guess you could probably, if I just look quickly, system logging, no, my memory is terrible. That's why I'm so good at documenting. But if there's VRRP, there is VRRP in logging. Okay, so you would have something there. But also you probably want something else to log the event, like the dude or any other network node manager, and keep a history of, because I don't suggest using a router as your main information database, right? So you might want to use not a SNMP, but what's the other protocol? 123? No, what? Syslog. Thank you. Now, if I had a pen, I would throw you one. Yeah, well, I mean, processing and finding information is not a big deal, really. I mean, just a little UDP packet that's being sent. So, yeah, sorry. If you want to keep a history of the events, I would definitely go the syslog way. I mean, oh, yeah, definitely. You can configure syslog, and whatever you've done in your system logging subsystem, you can always add an extra action or, and send it to your syslog server, which is a different way to go to. Oh, yeah, I mean, anything that can happen. I mean, the worst that you could do is activate, debug everything, and send it to a syslog. I mean, for those who are on in the Cisco world, I once had a friend of mine do debug all, and then we had to reboot the server period. I mean, the switch, I mean, a 4500 switch, I mean, she really killed it, but you could probably do the same in MikroTik and just do target your events and send them to syslog. If it you mean it doesn't work with non-MikroTik? Yeah. With non-Cisco, no. I mostly played with Cisco and MikroTik. I know, remember, like I said earlier, Cisco, they had PVSTP, and that was peachy to use. But other non-Cisco, no, I've never had experience. Questions? Questions? That's it. Well, look, thank you very much for your attention. My throat is raw and dead. And, okay. Thank you, MikroTik, for your first Mom in Canada. Let's hope we'll have more. And enjoy the rest of the show. Thank you, guys, gals.
But I got hold up. Oh, okay. I'm presenting a different way.